We are now working on how to write verbal and numerical expressions. We have been working with algebraic expressions with all of the combining like terms and distributive property problems that we've been working on. Now we're going to learn how to take it from a written form and turn it into those numerical and algebraic forms that you can see. Again, as always, remember, hit pause in order to copy down any of the notes that you need, as I can just keep moving through on the video. Variable. A variable is a letter used to represent a value in a mathematical expression or an equation. It can be any variable. Usually, it's just a single variable, x or y. If it is grouped together as two variables, such as xy, that means it is multiplying. So that would be x times y. Variables are simply one letter representing a number. Each one of these would represent a different number then. A verbal expression. A verbal expression is an expression written as a word phrase. For example, 2 plus 4. Those are the words. A number increased by 2 are the words. They are words that I read, words that I say. Therefore, they are the verbal expression because they are written in words. Excuse me. A numerical expression is a mathematical phrase that contains only numbers and operation symbols. A numerical expression is a mathematical phrase that contains only numbers and operation symbols. You've been dealing with these since the beginning of your education. Examples below: 60 plus 25, 42 divided by 7. Last but not least, we have an algebraic expression. An algebraic expression pulls in the new pre-algebra 7th grade terms of variables and adds them into your expression. An algebraic expression contains not only numbers and operation symbols, but it also contains variables as well. Your examples are 3x plus 5 or negative 5x minus 6. Those are all examples of different algebraic expressions. In class, we worked on sorting these into different categories. We're not going to go over all of them, but what I do want to do as a quick example is let's look at 3 plus 6. Notice that there are no variables. It is only numbers. There are no words. So that would go into the numerical expression. That next problem of x minus 12, that has a variable. The variable turns it into algebraic. Down here, all we have are words. When all you have are words and no symbols, no numbers, no variables, you have a verbal expression. We have many different key words that we can use when we are trying to determine and translate verbal and algebraic expressions back and forth. Some of the words, and I'm not going to make an extensive list here, but some of the words we look for are the words some, more, increase, profit, deposit. All of those are words that might say that we're adding something. For subtraction, we have difference, less than, or less. 7 less than a number. We might have withdraw, we might have loss. some words along those lines. Multiplication, we would have times. Multiply. Product. For division, we might have words as divide. Quotient. Maybe put into groups. Again, we have a handout that we'll give in class, or that you had in class, that has much more detail to it with the different types of vocabulary you might see. When we are looking at the word phrases, our job is going to be to transform them into algebraic or numerical expressions. So if we look at this first one, 9 more than a number, I have to think to myself, I don't know what this number is that they're talking about. Whatever this number is that they're referencing, I don't know. All I know is I want 9 more than that. So I'm going to say, well, my number could be anything, any number, so I'm just going to pick n for any number. And I want 9 more than that, so I'm going to add 9 because I need 9 more than my number. This next word is sum. What is sum? Well, sum is adding together. So again, it's the sum adding together 9 and some number, which is the same exact expression. A number plus 9. Here's our word right there to tell us we're adding. A number increased by 9. The total. If a total, I'm grouping it together. If I look here, I have 4 subtracted from a number. Now, this is always tricky. 4 subtracted from a number. Well, in order to take 4 away from something, I need to know what something is first. So I need to know, well, what is this number? And since I don't know, I start with n, or x, or a, or r. I'm going to stick with n for number. And now I need to take 4 from that. Subtract 4 from a number. Again, as I move down the list, I have minus, that's another word. Less than is another word to signify that I was subtracting. Decreased by, and difference. 6 multiplied by g, 6 times a number, the product of g and 6. Again, here are my words telling me what symbol I'm going to need to use in my expression when I write the algebraic expression. 6 multiplied by g. Now, can I go multiplied by g? Not anymore. That is a big no-no. I cannot do that anymore because that is now 6 times x times g. I need to make sure that I either just write them side by side or I put the dot in between. Last but not least, at the bottom, we might have divided by, quotient of, or divide. All of these would start with a variable and divided by 5. We could put the little division sign with the 2 dots and the bar, but it'd be better if we start working towards the fraction form of that. Your job is to write a word phrase for each of these. I suggest that you pause the video, complete it, and then come back for an answer. When I have these, I read 5 plus a number d. I see that plus is my magic word. I need to take 5 plus a number d, and I could do that. Because addition is commutative, I could flop these around and have d plus 5, but that does not work for every problem. The next one, the product. I look at my list and I know that product means to multiply, so it means I'm multiplying 5 times g. So I put that answer. Excuse me. 11 fewer than a number f. That's a new one we haven't talked about. But if I wanted to have fewer than something, I need to know what that something is first in order to have fewer than it. So I need to start with that F and then take away the 11. I oftentimes like to think of replacing that end, the number F, with the word age. 11 fewer than my age. Well, if I needed to find 11 fewer than my age, I'd have to start with my age and take away 11. The next one, 17 less than H. 17 less than H means I need to start with the H and take away the 17. Similar to the problem above. Again, try these and then come back. Now, hopefully you notice that these are a little bit different. There's multiple steps here. Right here it's telling me to multiply, and right here it's telling me to reduce. So I have to read the whole thing, and it says 4 multiplied by the cube of t is reduced by 5. Well, first of all, I need to know what cubed means. Cubed means to the third power. So I have 4 being multiplied by t to the third power. 4 is being multiplied by t to the third power. Then that is reduced by 5. So this whole group is reduced by 5. Because order of operations tell me I multiply before I subtract, I don't have to put any parentheses in this problem. Sometimes students like to. They like to throw little parentheses around here to show that that has to be done first. The next one, again, these are multi-step. The sum of 10 and twice the square of j. So what do I need? I need a sum. I know that sum means that I add. What am I adding? I'm adding 10 and twice the square of j. So I need to take 10 and I'm going to add it with twice the square of j. So if this is j, remember squared is where I have the exponent of a 2. But I need to take twice that. To twice something, that sounded silly, but to take 2 times something, I multiply 2 times. That's twice. That doubles it. If I then come down to the bottom here, I have 2 divides the difference between 8 and r raised to the 4th power. Holy cow. So first of all, 2 is going to divide something. What is 2 going to divide? It's going to divide the difference. All right? So I know that if this is my division sign, that 2 is going to go on the bottom. Because 2 is going to divide whatever's happening on top. Well, what's happening on top is a difference. Difference, again, means to subtract. So I need to subtract something. What am I subtracting? 8 and r raised to the 4th power. So on top, I'm subtracting 8 and r raised to the 4th power. Today's homework won't have quite so complicated of a problem, but it's very nice just to see how do I read these and how do I see what's going on, looking for those key words. The square of b added to 6. What does square mean? Means to have a little raised power of 2. So I have the square of b and I need to add that to 6. So I had the 6 and I added b squared to it. Again, because of commutative property, these could go in either order, but that's not always the case for all problems. Next, the cube of f is subtracted from the 2/9. The cube of f is subtracted from the 2/9, which means I need to start with the 2/9 and then subtract the cube of f. Remember, the cube means that's the 3rd power. Sorry, that's really close. 3rd power. The cube of the total of x and 2. Now, this one is super tricky. What do I want? The cube. The cube of what? The cube of the total. So I know that whatever I have here, I need to take a cube of, whatever the total is. The total of what? X and 2. And if I was going to total something, I was going to add them together. What we need you to remember are the basic words for adding and subtracting, multiplying and dividing to use as hints. We also need you to remember that the word variable means any letters. We need you to remember the word variable from the notes that we took earlier. Again, in class, you'll get a list of all the different words and what they mean, but eventually you'll want to just start to memorize those the best that you can. There are many different resources available online for you. If you would like to try a few extra problems, go ahead and try Khan Academy and research writing expressions, and he would have a few more practice examples that you could complete online to see how you are doing. Thank you for your time.